Hello everyone, my name is Sudheer Kumar, Assistant Professor of Mathematics in MLR Institute of Technology. Today I am here to give presentation on this non-exact differential equations to find method of integrating factors of method 3, 4 and 5. Method 3 reducible to exact differential equations, method 4 and method 5 reducible to exact differential equations and problems on it. So method 3, how to find the integrating factor, let us see. See, if the differential equation mdx plus ndy equal to 0, if it is not an exact differential equation, then the integrating factor will be 1 upon mx minus ny, provided this denominator value mx minus ny should be not equal to 0. This integrating factor is applied only if the given differential equation is of the form y into some function of x and y dx plus x into some function of x and y dy equal to 0. This is a standard form. If it is in the standard form and the equation is not exact differential equation, then we can say that the integrating factor is 1 by mx minus ny, right? Let us solve this example. Solve the differential equation y into 1 plus xy into dx plus x into 1 minus xy into dy equal to 0. First of all, let us check whether the given equation is in this form or not. If it is not in that form, let us reduce into that form. So already the equation is in this form, mdx plus ndy equal to 0, where m is equal to dx coefficient, that is y into 1y plus x into y to y, xy square. Similarly, dy coefficient is n, which is x minus x square y. So what is the condition for exactness? Dou m by dou y, dou n by dou x should be equal. Let us check it. So dou m by dou y means y derivative is 1 plus x into y square derivative 2y, so it is 2xy, and dou n by dou x, x derivative is 1 minus x square derivative 2x, y as it is. So this is 1 plus 2xy, this is 1 minus 2xy, both are not equal. So dou m by dou y not equal to dou n by dou x. So the condition is not satisfying. So given equation is not exact. If the given equation is not exact, we have to reduce that equation into exact differential equation by the concept called integrating factor. So here the given equation in this standard form, we can take y as common in the first term. Similarly, in the second term we can take x common. So this is in the standard form. So we can write 1 by mx minus ny as integrating factor. So we can calculate 1 by m into x minus ny as 1 by 2 x square y square. This is the term called integrating factor. Now after getting integrating factor, we have to multiply this integrating factor with the given differential equation 1, then it will be converted into exact. Let us see that. So equation may be rewritten after multiplying with this if, means integrating factor. So I am multiplying this integrating factor with the given equation. Now this is reduced to equation 2 after multiplying. Again this is in this standard form, m dx plus n dy equal to 0. Here this is now our new capital M, this is an n, 1 by 2x y square minus 1 by 2y. Now let us check the condition for exactness. So dou m by dou y, first term is 1 by 2x square y. We are differentiating this with respect to y, means 1 by 2x square is constant. Derivative of 1 by y is minus 1 by y square. So this is minus 1 by 2x square y square. Similarly, dou n by dou x is minus 1 by 2x square y square. Both are equal. So this condition is satisfying. So the given equation 2 is exact differential equation. Now it is reduced to exact differential equation. Once it is exact differential equation, we know how to find the general solution of that. So general solution is given by integration of m dx. This is compulsory, where y is treated as constant, plus integration of terms in n excluding x terms, into dy is equal to some constant c. So first m means 1 by 2x square y plus 1 by 2x dx, where y is constant dx, plus in this I have x terms, I don't want this, only consider minus 1 by 2y integration dy. So let us integrate that keeping y constant only in the first term, that is minus 1 by 2xy plus 1 by 2 constant, integration of 1 by x is log x. So 1 by 2 log x minus 1 by 2 into integral of 1 by y is log y equal to c. So this is the general solution for the given differential equation. Now let us see another method to find the integrating factor if the given differential equation is not exact. If dou m by dou y minus dou n by dou x divided by n, this is only purely function of x, so I am representing it with f of x, then integrating factor will be e power integration of f of x dx. And method 5 is if 1 by m into dou m by dou y minus dou n by dou x, if it is purely some function of y, no x terms, g of y, then the integrating factor will be e power integral minus g of y dy. Let us see this. Solve the differential equation x cube plus y square plus x into dx plus xy into dy equal to 0. Now this is in the form of m dx plus n dy equal to 0, where m is x cube plus y square plus x and n is equal to xy. So what is dou m by dou y? We don't have y terms here, so it is 0. Y square derivative is 2y, x derivative is 0 because no y terms. And n is equal to xy, so we are differentiating n with respect to x, so we get y, both are not equal, so dou m by dou y not equal to dou n by dou x. So the given differential equation is not exact differential equation. Now let us see this. Consider the value of dou m by dou y minus dou n by dou x. So I am considering this term 1 by n into dou m by dou y minus dou n by dou x. This also can be written like this: dou m by dou y minus dou n by dou x divided by n, or 1 by n into dou m by dou y minus dou n by dou x, both are same. So this value is 1 by x. So this is purely x terms, so I am representing it with f of x. When this value is purely some function of x, then what is the method says? The integrating factor is e power integral f of x dx. So here f of x is 1 by x. So integrating factor is e power integral 1 by x dx. So integration of 1 by x is log x, e power log x is x. So here integrating factor is x. Now after getting integrating factor, we have to multiply the given equation with the integrating factor, right? So let us multiply the equation with this term x. Now it is converted into equation, let it be equation 2. Now again this is in the form of m dx plus n dy equal to 0, where m is x power 4 plus xy square plus x square and n equal to x square y. So if you differentiate this with respect to y, dou m by dou y, this is 0, this is 0, so we get 2xy. Dou n by dou x is also 2xy, both are equal. Now this equation 2 is exact differential equation. After multiplying the equation with the exact integrating factor, we can easily say that the given differential equation is converted into exact differential equation. Once it is made exact, let us find the general solution. Let us write the formula: integral m dx, where m is y is constant, plus integral of terms in n other than x terms or excluding x terms into dy is equal to c. So this is m dx plus, since there is only one term in n, so we can't find any term other than x, so let us keep 0 here. integral 0 dy. So integration of this is x power 4 integration is x power 5 by 5 plus y square as it is, integral x dx is x square by 2, x square dx integration is x cube by 3. So this is a general solution, right. Let us solve another problem using this method. Solve the differential equation x square minus y square plus 2x into dx minus 2y into dy equal to 0. So let us write down m and n. So dou m by dou y is minus 2y. There is no x terms, so dou n by dou x is 0. Both are not equal. So we say that the given differential equation is not exact. Now when the given differential equation is not exact, by method 1, method 2, method 3, trial and error method we can apply. So we cannot apply this method 1 by mx plus ny because the given equation is not homogeneous. So let us apply next method 1 by mx minus ny. When will you apply this method as integrating factor? The given equation should be in the form of y into some function of x and y dx plus x into some function of x and y dy equal to 0. The given equation is not in this form, so we cannot apply this method also. Next method, coming to this. So let us consider 1 by n into dou m by dou y minus dou n by dou x. So let us check whether this term is consisting of purely x terms or not. So dou m by dou y minus dou n by dou x, this value is minus 2y. So minus 2y divided by n. N is minus 2y. So both are cancelling, we get 1. So let us assume that this is some function of x. Now integrating factor is e power integral f of x dx. So e power 1 dx is x. This integrating factor we have to multiply with the given equation, then it will be converted into exact differential equation. So after multiplying, this is how we get the equation. So again this is in the form of m dx plus n dy equal to 0. Now after writing m and n, new m and new n, dou m by dou y, dou n by dou x, we are getting both are equal. So this equation 2 is exact differential equation. Now let us find the general solution of this differential equation. So solution of this is integral of m dx, new m, treating y as constant. Here in n we have only one term minus 2 e power x into y. So excluding this term, so this is 0. So integration of this is x square minus y square plus 2x into e power x minus 2x plus 2 into e power x plus 2 into e power x equal to some constant c. So this is the general solution of the given differential equation. Now let us solve one more problem using another method. Solve this differential equation y power 4 plus 2y into dx plus xy cube plus 2y power 4 minus 4x into dy equal to 0. So m and n, let us write down this. Dou m by dou y is 4y cube plus 2 and dou n by dou x is y cube minus 4. Both are not equal, so the given differential equation is not exact. When it is not exact, check whether we can apply the previous 3 methods, whether we can apply it or not. If not, come to the next method. So consider this term dou m by dou y minus dou n by dou x by m. So 3y cube plus 6 pi y power 4 plus 2y. So this value, if you take in 3 in y cube plus 2 divided by, here y, if you take common, y cube plus 2. So y cube plus 2, y cube plus 2 cancel, we get 3 by y. Since we don't have any x terms, this is purely y terms, so consider this as some function of y, that is g of y. So what is the integrating factor? E power minus integral g of y or e power minus integral 3 by y dy, which is e power minus 3 into log y. So this can be written as e power log y power minus 3. So e and log cancel, y power minus 3, this is 1 by y cube is the integrating factor. Now let us multiply this integrating factor with the given equation. This is converted into like this, equation 2. Now let us find the general solution. So general solution is integration of y plus 2 by y square dx plus, here I don't want x terms in n. So here x is there, I don't want this. Here x is there, I don't want this. Only consider integration of 2y dy is equal to some constant c. So integration of y dx is this. This is completely constant. Don't integrate that. Integral dx is x plus. Here y is not constant. So integration this 2 into y square by 2, 2 to get cancelled, plus y square equal to c. So this is how we find the general solution for the exact differential equation. Thank you.